Imagine the might of a rocket, its engines roaring, flames licking the launch pad as it surges upward, carrying humanity's hopes beyond the grasp of Earth. For decades, this vision has been fueled by chemical rockets, the workhorses of space exploration. But as the countdown to Mars ticks on, a daunting reality stands in our way. Distance. Mars, the red jewel of our solar system, beckons, but the journey is perilous and slow. 9 months in the void, with every moment exposing astronauts to the dangers of deep space, cosmic radiation, and psychological isolation. The challenge is not just technical, but existential. To truly conquer this gap, we need a leap beyond convention, a fuel that's not merely stronger, but represents the ultimate edge of energy itself. Enter antimatter, a substance so rare, so volatile, it borders on the fantastical, yet holds the promise to revolutionize our reach for the stars. In this scientific exploration, you'll discover the awe-inspiring potential of antimatter propulsion and why it stands as the pinnacle of rocket technology. You'll understand the staggering efficiency of antimatter, up to 1,000 times greater than nuclear fission engines. You'll see how a mere 10 milligrams of this extraordinary fuel could slash the Mars voyage from a grueling 9 months to a mere 45 days. But you'll also confront the formidable obstacles, the agonizingly slow pace of production, and the lethal gamma radiation unleashed in each annihilation event. Let's journey through the science, the promise, and the peril of antimatter. Why is antimatter considered the holy grail of propulsion? At its core, antimatter engines exploit the most energetic process known to physics, the annihilation of matter and antimatter. When a proton collides with its mirror opposite, an antiproton, their mass is not just burned off, but fully converted into energy. No ash, no waste, just pure force. This annihilation releases a torrent of charged particles, mainly pions, which can be harnessed and directed by powerful magnetic fields to propel a spacecraft at unimaginable speeds. The numbers are staggering. Specific impulse, a measure of how efficiently a rocket uses its propellant, is the key metric here. Chemical rockets, like those that sent Apollo astronauts to the moon, achieve a few hundred seconds. Nuclear thermal rockets might reach 1,000 seconds. But antimatter rockets? They boast theoretical specific impulses up to 1.4 million seconds. Even with a modest system, say, achieving just 5,000 seconds of specific impulse, current crew modules could reach Mars in 3 months, slashing the journey by 2/3. But with optimal design, leveraging every spark of annihilation, the time falls further, a mere 45 days, made possible by just 10 milligrams of antimatter. Imagine holding a single grain of sand, knowing it contains the power to hurl a spacecraft across millions of kilometers in a matter of weeks. Yet, antimatter is not forged from myth. It is real, created in particle accelerators, and studied in laboratories around the world. The challenge isn't in the science, it's in the scale. Producing antimatter today is painfully slow. At current rates, it would take 100 billion years, far longer than the age of the universe, to make a single gram. Laboratories aren't designed for mass production, and each microgram costs millions. But progress is being made. Scientists are pioneering new techniques to accelerate the creation of antiprotons. Some optimistic estimates hint at the possibility of producing 20 grams per year if we invest hundreds of millions into advanced technologies and infrastructure. This is the bottleneck that defines the future of antimatter propulsion. But with great power comes great peril. The annihilation reaction, while elegant in its efficiency, is ruthless in its byproducts. Nearly 40% of the mass energy is released as high-energy gamma rays and fast-moving pions. Radiation so intense, it can shred human tissue and fry sensitive electronics in an instant. To protect astronauts, spacecraft must be fitted with thick shields, layers of lead, concrete, or even water designed to absorb and deflect the deadly rays. These shields add substantial mass and complexity, demanding new engineering solutions and innovations in material science. Heat generated by the reaction must also be carefully managed. lest it damage the very systems meant to sustain life. Despite these daunting challenges, the allure of antimatter is irresistible. It is not just a fantasy or the stuff of science fiction. Antimatter exists and its properties are well understood. It offers a pathway to transform interplanetary travel from an epic ordeal into a swift journey, measured not in months, but in weeks. With antimatter, Mars is no longer a distant horizon, but a nearby neighbor. Yet, before we can harness this cosmic power, 3 obstacles must be overcome. First is production, scaling up the creation of antimatter from laboratory trickle to industrial torrent. This requires breakthroughs in accelerator technology, storage, and global collaboration on an unprecedented scale. Second is control, safely storing and manipulating antimatter, which annihilates on contact with ordinary matter, demands magnetic bottles and containment fields of extraordinary precision. And third is shielding, developing effective, lightweight protection against the lethal radiation produced, ensuring both crew and electronics survive the journey intact. The race into space is not merely about distance, it is about the mastery of energy. The fuel that carries us to new worlds must be as extraordinary as the destinations themselves. Antimatter, with its unrivaled power and daunting risks, stands as the ultimate frontier. Its development will push the boundaries of physics, engineering, and human ambition. As the sun sets on Earth and rises over the barren plains of Mars, the future glimmers with promise. The dream of swift interplanetary travel is no longer confined to the pages of science fiction. With antimatter, humanity stands on the brink of a new era. The challenges are immense, but so too are the rewards. The red planet awaits, and with antimatter as our key, the door to the cosmos swings open. The journey to Mars may soon be counted not in months, but in weeks, a testament to the ingenuity and daring of the human spirit.